Welcome back. I've been doing quite a few Trustsec videos this week, so this will probably be the last one I do in regards to Trustsec, at least for this week. This one is going to be less about configuration and more about things to think about when it comes to brownfield environments, because most of us don't have the luxury of a greenfield environment, and generally some things to think about when it comes to scaling your Trustsec design. So to start out, we still have the same configuration we had when we ended the last video, so I'm going to take a look at the policy sets really quickly and kind of show you how it's configured. So let's navigate over to Policy and Policy Sets, and the policy set I'm using is the Security Demo Wired Closed. Let's expand the authorization policy, and as you can see here, I have two sets of results for each authorization rule. I have the results that are the authorization profiles, and then I have the security groups on the other side. So basically what's happening is it's using this this policy set. When it delivers an authorization result, it's using an authorization profile, which includes a downloadable ACL, which let me go ahead and expand that. And it's also including a security group tag, which is fine. I mean, but it can also be overlapping. And one of the benefits of Trustsec is not having to fill up your TCAM table. So let's go ahead and exit out of this really quickly. And let's go ahead and take a look at the Radius Live logs. I have one client, at least, that's logged in. There I am. And let's just expand this so I can see what port on switch 1 it's connected to. So it looks like it's gig 1/0/47. So I'm going to go ahead and pull up my switch really quickly and show you the authorization session from the switch level. Yeah, I'm going to also expand this. As you can see down here, under more details for the authentication and the authorization, it delivered the Cisco AV pair of the security group tag and the user ACL. So if I do a show authentication session interface G1/0/47 details, I can see that's both of those are delivered. So the security group tag, that's fine. The ACS ACL, that's the downloadable ACL. It is a per user ACL. So even if somebody logs into another port on the same switch and it's the same ACL, it's going to have those last digits there are going to be different because it's a per user ACL. So it'll download it again and apply it to the TCAM table for the duration of that session. Well, if you're doing a brownfield design, it might seem like it makes sense to do it this way, where you have authorization rules that have both downloadable ACLs and security group tags, because most devices will ignore the security group tags if they don't support it. But there's a better way to do that, because for the devices that are using security group tags, you don't want to just continue to use the TCAM space, especially if those ACLs are getting more. Those ACLs are getting more robust. So let's say we have a big an enterprise network, and we have this site over here that this small branch is a non-Trustsec enabled device. Maybe it's got a bunch of third-party switches or whatever else. But then we have this other switch here that these other sites here that are Trustsec capable. Well, we don't want to go ahead and use the same policy set, in my opinion, because I think that there's a better way to do this, and one that won't be doing a bunch of downloadable ACLs to those Trustsec networks. So let's go to Administration and then Network Device Groups. If you watched my previous video on Network Device Groups, this is going to be very similar to that. So I'm going to create a new root network device group, and I'm going to call this Trustsec Capable. Then I'm going to create another group underneath that, and I'm going to call this this probably won't let me do it because it's Trustsec Capable. Yeah, same name, so I'll just remove that capable part and I'll just call it Trustsec. Okay, so Trustsec is going to be my Trustsec capable devices. Let's add another network device group. And we're just going to call this non-Trustsec capable, or non-Trustsec. and put that under the same root. Now remember, these network device groups are just tags. They're not doing anything until we use them in a policy and then define in our network devices what falls under a Trustsec or non-Trustsec capable. It could be pink fluffy bunnies, but to emphasize the point, let me duplicate the policy I've been using. And I'm not going to like enforce it or anything. I'm just going to kind of show you how I would do this for those different networks. So I'm going to call this one Trustsec capable. And for the condition to meet this policy set, I'm going to add a new condition. And that's just utilizing that network device group that we talked about before. Trustsec capable. And we're going to call this one Trustsec. This one, anything that's tagged as a network device that's Trustsec capable, it will at that point allow it to hit this policy set instead. This will be the one for our non-Trustsec capable endpoints. The only difference I'm going to do is for the device network device group, I'm just changing that to non-Trustsec. So save this policy really quickly. And as you can see here, the only thing that differentiates these two policy sets is the fact that we created this the network device group that's separating them. So under this Trustsec capable one, I'm just going to go ahead and remove these authorization result profiles. Fat fingers today. It's been a long day. Sorry. And yeah, I keep clicking the wrong thing. And I'm just going to rely on Trustsec tags for that one because, you know, those are my sites that have already been converted over to security group tags. There's no reason to continue to download ACLs and downloadable ACLs and maintain those for those sites because at this point, it's just taking up TCAM space, and that's not why we're using Trustsec anyways. We want to simplify that policy for those. So for those sites, we don't want to have like anything like an overlapping security group policy and a downloadable ACL. So we're just going to stick with the security groups and keep it at that. Keep it simple, the KISS principle. And as you can see here, it's just security group tags on the side and no more authorization results. Now let's go back to our policy and do the exact opposite for the other groups. So I'm going to go ahead and expand the non-Trustsec capable one. And in this case, I'm going to make sure that looks like I copied the wrong thing. I'm going to make sure that the security group tags are removed, and I'm going to define the authorization results instead. Now you could keep the security group tags in there if you really wanted to, but and for Cisco devices, if they don't understand security group tags, they usually just ignore that Cisco AV pair. I can't really vouch for every third-party device, so just to be safe, I would so it doesn't drop the whole entire radius authorization packet, I would just probably say keep them separated. And this is a way to where you kind of focus your downloadable ACLs or any different authorization results on those sites that are non-Trustsec capable or the ones that you're solely converting over, and then have a more pure policy that just has security group tags for those sites that are Trustsec capable. So I'm going to go ahead and save this. And again, I'm not going to test this out. This was more of an example of if I had this environment that had different capable devices, like a Brownfield environment. Now, if I wanted to define what would hit which policy set now, I would just go into the network access device and I would just basically pick which network device group that guy should be hitting. So the non-Trustsec capable devices, those I would just define here that's non-Trustsec capable, and it'd hit that new policy set. Trustsec capable ones, define it here again, hits that policy set I want it to hit. So hopefully that made a little bit of sense. Now let's dig into design a little bit more. So the next thing I want to kind of dig into is where enforcement is done in a Trustsec environment. So the thing that the enforcement device needs to know is the source and destination tag in order to enforce at that point. So let's take a look at the design, the imaginary corporate network we were looking at before. So let's say we have this user connected here to this switch A. We have another user connected on the same switch. And according to our security group policy, these guys should never talk to each other. So if this user tries to, for example, to communicate with that user on that same switch, it'll enforce it because it knows that port 1 has this tag and port 5 has this tag, and it'll block it. What kind of blows your mind when you're working with Trustsec at first is not what happens on a local switch. Now that's really cool that you're able to enforce based on a layer 2 perspective right there. But what if this guy is in another site and they're not allowed to talk to each other? So just based on the natural flow of things, if there's no other enforcement points, it would go across the WAN, it would come in here, and because that packet is tagged, at that point it would be, since the access layer switch knows the destination tag and it knows the source tag because it's tagged in line, at that point it would be dropped at the destination. And again, this does go against what we know of ACLs putting it at the destination for, closest to the source. But if we had something like SXP where they knew each other's IP to SGP mapping, it would actually be enforced at that layer, that router at the edge, because it would know the destination tag it's going to. Now you don't necessarily have to do this. In fact, I wouldn't encourage having every single router know every single IP to SGP mapping, but it is something that is capable of being done. And I just want to kind of let you know how that enforcement is done. If whatever device knows the destination tag and the source tag, it will do the enforcement because it looks at its own security group policy and it makes that decision. That's why you don't typically see it done in the ingress to the network. So with that being said, let's go ahead and go back into design and kind of talk about where SXP kind of plays a role in all this and what we, clarify some of the things I talked about before. So in this part of the video, I'm just going to dig into SXP a little bit more. It's pretty powerful in terms of being able to share kind of the IP to SGP bindings, across a WAN, across a non-Trustsec cloud. In this environment, like this diagram right here, let's say we have two devices connected over a WAN via VPN. So in my previous example, if you watched my SXP video, I kind of made said the WAN was analogous with, not being Trustsec capable. If you're just dropping it onto the WAN, no VPN, yeah, that's probably 100% true. And then you'd have something like SXP to communicate bindings from one site to the other site. And at that point, it's untagged at the egress of that LAN, and then retagged when it hits the other site. But more, what I see most commonly in customers is I see it kind of like going over a third-party firewall or a third-party device at the edge. Maybe the firewall understands it, but the router doesn't. This is a situation where we would use something like SXP to just kind of do that. So let me just kind of draw this picture. Let's say that we have the site and we have a Palo Alto Networks firewall sitting here between the router and the switch. Well, the whole entire site is Trustsec capable, and say a packet comes in with the Trustsec tag of 5. So let me draw this here. I have the worst drawings, so apologies for that. But I'm trying to make the point, visualize the point here. So once the switch receives it, what it would do is it would untag that SGT tag, and then communicate the IP to SGT tag binding over via SXP to this router right here. Once that router, that packet will go through the firewall, and once that packet gets over to that router, it retags it. So what about the WAN? Well, the good news is if you have ISRs or not just ASRs, but ISRs as well, you can actually use VPN to keep those tags still in line. There's actually a field in IKE v2 that we utilize to put the tag in. So let me go ahead and pull up a document really quickly. So this document I'm pulling up is incredibly useful. This is a point in time. I'm looking at the version of it from April 2nd of the newest one, April 2nd of 2019, but check to see if there's a newer one. This is the Cisco group-based policies, and it has a lot of the scalability limits and the features that are capable per platform. So let's scroll down to ISR really quickly. So I'm just zooming in. Okay, so the 4400s, the older ISRs, G2s, they all support IP SGT over, DMVPN, IPsec VPN. That all would still continue to be in line, so you wouldn't have to use SXP for that. Oop, let me delete that. Yeah, so as you can see here, it's still considered inline SGT tagging because it's in that VPN. In that VPN packet, it's still putting the SGT tag. So once it's decrypted at the other end, it would actually be still be inline tagging, and it would just drop it off into the LAN with the correct tag. So there's different kinds of VPN support for inline tagging, and let me just kind of spell it out for you. So the first one is FlexVPN, and FlexVPN does utilize IKEv2 always, so that is 100% capable. Then DMVPN with IKEv2. I can write today. The next one is GetVPN, which, if you know anything about GetVPN, that's only for private LANs or private WANs. And the other one is site-to-site VPN with IKEv2. So again, you can have the inline tagging continue. You don't necessarily have to use SXP for everything. You can still continue to use these and propagate them as that traffic is moving across your private or your public WAN. So that's still not an issue that you have to have like aggregation points in every network that has IP to SGT mappings for every single device in your network. Not at all. This is where kind of VPN kind of propagates and makes it useful. So let's talk about how we might use SXP to our advantage. There's a couple different things I can think of, but let me go ahead and start out by kind of drawing a picture of ICE really quickly, and I'll explain kind of how we would build this up. So let's say we have a bunch of servers in our data center, and there's we want to propagate static IP to SGT mappings. Maybe there's a way we can't propagate inline to all the way to the data center, the source tag from the user sites. So we want to find a way to propagate them to the actual branch sites. So one of the things we could do is we could, if there's a router or switches in the data center, we could create a SXP connection for every single device, every single branch out there, something to every branch. But that's not really how I would do it. What I would do is, since I don't want ICE communicating every IP to SGT mapping everywhere, I would find some core devices in every single branch, and I would create the static IP to SGT mapping inside of ICE. And then I would do speaker only, where ICE is just communicating to those aggregated points inside of the each branch. And it doesn't have to be in every single device. Don't do that. You would pick a hardware platform that would meet your needs, something that everything needs to communicate through, and that would become the enforcement point, because not only would it have the source tag, but it would have the destination tag if it's going towards the data center. Another thing that you might want to consider is if you have an ACI data center, what you can do is you can integrate that with ICE, where essentially there's an EPG to security group tag mapping, and ACI and ICE are able to communicate that between each other, so they're kind of able to map between, and ACI would fit in the contract that it needs to go into, while ICE would fit that into the security group matrix that it needs to. And it would, if you wanted to, you can push that information out via SXP. So just again, something to be aware of. So the other thing I wanted to talk about is limitations. Every piece of hardware out there has limitations. When we talk about downloadable ACLs, there's TCAM limitations. When we talk about SXP and security group tags, there's a limit on how many tags a physical, or how many IP to SGT mappings a physical, one piece of hardware can handle. So that's where I go back to this guide and I look at, what devices can accommodate what I need to communicate versus from IP to, via SXP and the IP to SGT mappings. And again, so as you can see here, each hardware platform is a little bit different, but they have a recommended maximum IP to SGT bindings. Some of these might be, probably are, limited based on hardware. So, any design for any large scale environment you do, it's all about design. Whether or not you're doing, a large scale routing design, large scale voice design, large scale firewall design, you wouldn't just deploy it and not think about design first. The same thing about Trustsec. It's all about design, and that's where I kind of, pull back from the configuration and talk about this first before before I finish this video series. We wouldn't deploy every IP to SGT mapping to the access layer devices, just like you wouldn't dump the entire BGP pool into from the internet into your 2960 XR. We look at what can accommodate like all the IP to SGT mappings from, say, maybe the data center. And if you notice, like on that document, like the old 6500s can support 256,000. If you scroll down, some of these firewalls can support, like the 5550 can support 500,000. So it's not really, if you do it in certain places, depending on what hardware, you should be able to accommodate all of your servers or all of the static mappings or subnets that you need to do. If you look on the ISR routers, even the old 1900s can accommodate 100,000 unidirectionally or 180,000, or the 4400 series ISRs support 750,000. So with the newest code. So again, this is stuff you can consider, but considering it, ice scales to, I very much doubt most of you are going to have millions of endpoints. This should be fine. So focus when you do an SXP design on these core layers. Check the firewall, check the ISR, check the core switch, and see what can accommodate the most IP to SGT mappings, and have that be what, if you have to communicate SXP over your WAN, have that be the destination. So we've talked about a lot in this video, and there's one last thing I'd like to talk about. Environments where you have mixed devices. So let's say you have a brownfield environment where some sites are on aged hardware, like could be old aged Cisco hardware that doesn't, like 10 years old, doesn't support Trustsec, or like, third-party devices, and maybe the edge device or the edge routers support Trustsec. So this happens a lot, and it's more of a design thing. Like how do you work around it? Because obviously you don't have most companies don't have the ability to upgrade all their switches right away. So you've got this access layer that doesn't support Trustsec right now, and then you've got that the part of the network that does support it, but the part where the users come in doesn't. So we've got those Trustsec capable maybe ISR routers. That's where we kind of we could kind of design a couple different things. So we could have an authorization result that provides a DACL or ACL from the on the access layer, but once it gets to that Trustsec capable device, we can do an IP to SGT mapping via subnet, IP address, just a static map, or a VLAN, just a static map that tags it right there at when it gets to the router. And depending on how your network's set up, you can have it continue inline tagging through the WAN using like VPN or something, or we can do tagging through like and communicate it over the WAN to ICE if you wanted to use SXP. So a couple different ways of doing it, but it's just something kind of be aware of. You still can design around having those sites like that. You don't have to just roll out new hardware day one and have in order to make Trustsec work. It's just all about design. With that being said, thank you so much for watching the video. I know we kind of went through a lot of stuff, but these are things I wanted to touch on before just giving you configuration videos and saying have at it.